JAMB 2023 question 4. We're given the dimension of a flower vase as this, with the upper radius of 16 centimeter and the lower radius of 8 centimeter and a slant height of 30 centimeter. We should find the curved surface area of the vase. So we are looking for the area embedded in this vase. But how do we go about that? Let's take a step backwards. If we complete this vase now to be in a cone format, okay, with a center of O, and we take it upwards, and let's label AB, CD, and EF. Now we can see that AB, O, or let's draw it out. We have this, and a circle. This is AB, and this is O. And likewise, if we draw the other one out, we will have CD and O. And this is resulting into a cone. We have the big cone and the small one. Now let's look at the dimensions again. We have AEB or SAAB with a bisector E at the center to be 16 centimeter. Therefore, we can conclude that AE is 8 centimeter and likewise EB is 8 centimeter. Similarly, we know that CD, the length is 8 centimeter. So we can come to a conclusion that CF, which is the bisector of CD, is 4 centimeter and FD is also 4 centimeter. So let's now come to this triangle here, or the cone. If we divide the cone, bisect it again, we would have a right angle triangle as when we bisect the cone. Similarly for CDO, a right angle triangle. The locator of this point is called point E, and this point is called point F. EB, according to the geometry that we have here, is 8 centimeter, and FD, according to the geometry we have here, is 4 centimeters. The slant height of BO, let's look at length BO, okay, is going to be 30, but not just 30, there is something missing here, X, so we call it 30 plus X. And the slant height for CDO is X centimeters. So we can see this is 30 plus X centimeters. So with this now, we can evaluate what X is. And once we evaluate what X is, we can apply the formula for the curved surface area. Remember that the curved surface area of a cone is pi r L. We know the radius, and all we just have to do is to evaluate the slant height of each. So let's evaluate X. So once we know X, we can evaluate the slant height of this cone, and we can also evaluate the slant height of this cone. So let's begin. We want to compare triangle A, or let's say OEB, and triangle OFD. Let's draw them out again. triangle OEB, and triangle OFD. OEB and OFD. EB is 8 centimeters. BO or OB is 30 plus X centimeter. FD is 4 centimeters. And DO is X centimeters. So we can use the principle of similar triangle. The principle of similar triangle. Such that we can say EB, okay, divided by FD is equals to BO divided by DO. EB similar to FD. Remember that both are right angle triangles. BO similar to DO. So EB now is 8 centimeters, just like we have here. FD is 4 centimeters. So this will result into 8 over 4. BO is 30 plus X. So we equate it. 30 plus X divided by DO, which is just X centimeters. Remember, we are applying similar triangle. So now we want to evaluate what X is. So let's cross multiply. Before we cross multiply, we can just divide this 8 over 4 and this will result into 2 over 1. So this will be 30 plus X divided by X. So cross multiply now. This will result into 2X is equals to 30 plus X. So if we come collect like times, so we have 2X minus X is equals to 30, and X is equals to what? 30 centimeters. Now if X is equals to 30 centimeters, let us, what now is the slant height of BO? BO will be 30 plus 30, which is 60 centimeters, and DO will be what? X centimeters, which is 30 centimeters. So with that now we can evaluate the curved surface area of each cone. Let's draw the diagram again. Or let's just copy this and we'll edit. Now we have BO to be 60 centimeters and DO 60 centimeters and DO to be 30 centimeters. We want to evaluate, the question says we should evaluate the curved surface area of the vase. The vase is ABCD. That means we are looking for the area embedded in this place. And to get the area embedded in this place, we have to evaluate the curved surface area of the larger cone and subtract the curved surface area of the smaller cone. Now let's call this radius R1 and let's call this slant height L1. Let's call this radius R2 and let's call this slant height L2. The curved surface area of a cone is equals to pi of a cone is equals to pi RL. R is the radius, L is the slant height. So with that done, the curved surface area of the vase, that's the flower vase in question, or let's call say the shaded portion here, is equals to the curved surface area of the large cone, okay, minus the curved surface area of the smaller cone. You know, the curved surface area of a cone is pi r L. The curved surface area of a cone is also what? Pi r L. So we call this, the large cone is 1, which has R1, L1. The small cone is 2, R2, L2. So we can see it here. Large cone, R1 of 8 centimeters, okay, and L1 of 60 centimeters. Small cone, R2 of 4 centimeters, and a slant height of 30 centimeters. So let's substitute the values. Pi, the R1 is 8 centimeters, just as we have here, multiplied by 8. The L1 is 60 centimeters, multiplied by 60. Pi, the R2 is 4 centimeters, multiplied by 4, and the L2 is 30 centimeters, multiplied by 30. So with that, this will result for 8 pi multiplied by 8 multiplied by 60, we will have 480 pi, and 30 multiplied by 4 multiplied by pi will give us 120 pi. Remember the units, we are dealing with centimeters, and this will be what? Centimeter squared. Centimeter squared. So with respect to that, we have 480 pi minus 120 pi. The result is what? 360 pi centimeter squared. So the curved surface area of the vase is given as 360 pi centimeter squared, which is option D.